Welcome to part 3 of the vertical projectile motion velocity time graph. And in this video, we're going to be actually identifying which direction was chosen as positive when plotting a velocity time graph. Okay. But then so far, the work that we have done, we have asked ourselves 4 theoretical questions, right, that you need to ask yourself when analyzing a velocity time graph. So the first question was it a drop or a throw, right? So we said if it's a drop, then your initial velocity is equals to 0. Then if it's a throw, then your initial velocity is a certain value, and we've been using 2 as an example, right? And then the second question was where did the ball go? If the object is a ball, where did it go? Did it go upwards or downwards? But then if it was a drop, then we expect the object to go downwards, right? But then if it's a throw, it's either it can go up or it can be thrown down. So if it reaches the maximum height first, then we said it is thrown upwards. But then if it bounces first, then we say it was thrown downwards, right? And then after that, we talked about some of the properties of the velocity time graph, whereby we said if we have velocity time graph and we said the gradient of that line is actually the gravitational acceleration, which is 9.8, right? And then we also talked about the area under the graph, which is that area, and we said that area is your displacement. All right, so for this video we want to check which direction is actually chosen as positive. If you look at a graph, you have to be able to identify whether upward was chosen as positive or downwards was chosen as positive. So I'm going to use a simple scenario to differentiate the two, right? So let's say a ball is dropped. So if a ball is dropped from a stationary point, we expect the initial velocity to be equal to 0, right? So when we draw our graph, we expect the graph to start at the 0 point or at the origin. All right. So let me have a simple diagram on the side so that it's easier to understand. So let's say a ball was dropped from the rooftop, right? So if it's dropped, we expect it to go downwards in that direction. Okay. So for the first scenario, or for this particular question, I'm going to choose upward as positive first. So upward is positive. So let me look at my graph. I'll have the velocity on the y-axis and the time on the x-axis, right? Okay, so now if it's a drop, we agreed that your graph will start at the 0 point, right? And if it's a drop, we expect it to go downwards and it should bounce. Okay, so this is some of the theory that we have been explaining. If it bounces first, then it was going downwards. So it's the same as saying if it goes downwards, it's gonna bounce first, right? All right, so say I chose upward as positive. If you look at this ball, it's gonna go downwards, so it's gonna have a negative velocity here. So its velocity will increase in the negative direction because there's acceleration as the ball goes down, right? It accelerates with 9.8 meters per second squared downwards, which is your gravitational acceleration. So it means your velocity will actually increase in the negative direction. So it will move from 0 and increase in the negative direction. Okay, so where is the negative direction in this graph? This is your negative direction and that is your positive direction. Okay, so if I chose upward as positive, when the ball goes down, it's covering a negative because I said upward should be positive, then meaning downwards is negative. So it's gonna increase in the negative. So this is what will happen. It will increase in the negative direction. So if I choose upward, this is how my graph appears, right? It has a negative slope. So if it has a negative slope, we can see that up was chosen as positive. So now let us quickly represent this on another graph, okay? And on this graph, we are choosing downwards as positive now. And remember, this is a drop. If this is a drop, it will start at the origin, okay? So there we go, at 0 point. This is the positive velocity, this is the negative velocity, okay? So this object was dropped, initial velocity equals to 0. And if I said downwards is positive and the object is also going downwards, then it means it will cover a positive velocity. It will increase in the positive direction of the velocity. So meaning instead of increasing into the negative, right, it's going to increase in the negative direction up until it bounces. Okay, so we can actually spot the differences now. This line, it has a positive slope or a positive gradient. This one, it has a negative slope. So if it has a positive slope, we can simply say that downwards was chosen as positive. This is how we identify which direction was chosen as positive, right? So to simply maybe understand it or to remember it, we can say if the line is going down, if the lines are going down, which is your negative slope, we can say that upward was chosen as positive, meaning downwards is negative. Yeah, so it means down is negative. But then if your line has a positive slope like that going upwards, it means downwards was chosen as positive and upwards was chosen as negative. So this is how we identify our directions. All right, so let us look at a few graphs that we have been explaining in the previous videos. Okay, so this one is for this video. Let us look at this graph. So if one were to ask which direction was chosen as positive, okay, so you just have to look at the slope of your graph. Okay, so if it has a positive slope, downwards was chosen as positive. Okay, so this is what we have here. If it has a positive slope, downwards was chosen as positive. So we can simply say if the lines are going up, downwards was positive, right? But however, if we can look at a different example, if we look at this example here, which direction was chosen as positive, we can see that the slope of these lines is negative, right? So if it has a negative slope, we said upward was chosen as positive, and meaning downwards is negative, right? So you can simply see that if the lines are going down, upward was chosen as positive. And here, if the lines are going up, then downwards was chosen as positive. So it's actually sort of like the opposites. If the lines goes up with a positive slope, it means downwards was chosen as positive. But then if the lines go down with a negative slope, it means that upward was chosen as positive. So that is our next theoretical question that we have to ask ourselves when we're analyzing a question, right? So if we can analyze all of the questions that we have done before on this graph, right? And we have to analyze them in order. So the first question was it a drop or a throw? Okay, we can see that in this graph, the initial velocity is equal to 0. So the initial velocity is equal to 0, and we can conclude that this is a drop from a stationary point, right? So if we were to formulate our statement, we would say an object is dropped from a stationary point, because we can see that the initial velocity is equal to 0. Okay. And then question number 2, where did the ball or where did the object go? We can see that the object started by bouncing here. It started by bouncing before it reached maximum height, right? So, and it's obvious, because if you drop a ball from a stationary point, you expect the ball to go downwards to go and bounce, right? So this object went downwards. The object went downwards. So we are formulating the statement now. An object was dropped from a stationary point, and the object went downwards to bounce, right? We can see that it went to bounce. Those dotted lines represent a bounce. All right. And then the next question is, what is the physical quantity represented by the gradient of these lines? So you can see that this is a straight line here. This is a straight line, and also that is a straight line, right? And you can see that the slope of these lines are the same. They go up the same direction, right? And this is because the slope of that line and this line is the same, which is your gravitational acceleration. Gravitational acceleration. So this is the same thing. That is your gravitational acceleration. That is your gravitational acceleration. So now they might say, why do the two lines have the same slope? That's because the acceleration of a projectile is constant, right? Which is 9.8 meters per second squared downwards. All right, so that was the next question. So now the following question is, what is the physical quantity represented by the area under the graph? So the area we're talking about, that area between the graph and the time axis or the x-axis, that area between the graph and the x-axis, and that area between the graph and the x-axis. What does that represent? So the area under the graph, that represents your displacement. So in terms of calculations, you just have to calculate the area of those triangles, then you can get your displacement, right? And then in terms of the acceleration, you just have to calculate the gradient, but you don't have to calculate the gradient of a projectile, because it's constant, which is 9.8 meters per second squared. But we can calculate it if we have values, right? So if maybe the question said calculate the acceleration, you just have to calculate the gradient. Calculate the displacement, you just have to calculate the area under the graph. Okay, so now the next question is, which direction was chosen as positive, which is what we were explaining right now. Okay, so we said if the lines go up with a positive slope, then the direction chosen is actually the opposite. If the lines go up with a positive slope, then the positive direction was downwards. So we have answered all the theoretical questions so far. So that's it for this video, and then in the next video I'll be explaining more on the projectile motion graphs.